All right, let's clean up graphing polar equations today. And I put this picture of the unit circle up there because I want to remind you on the unit circle and every trig function, sine, cosine, tangent, all of them are periodic. Remember, that means they repeat. Okay, over and over and over again. And as you go around this unit circle and look at all of these values and coordinates all the way around, you can definitely see that those values repeat. Square root of 3 over 2 repeats. Square root of 2 over 2 repeats. 1/2 repeats. And the way that we clarified what those values are was with the bow tie. All right? So, with the bow tie, we can, speed all of this up, all right? But just to kind of clarify here on this diagram, here on these first coordinates, this is a 30-degree angle, which means this is 1, 2, square root of 3, all right? If I do the cosine of this 30-degree angle right here, I have adjacent over hypotenuse, and I get this value, right? If I do the sine of this 30-degree angle, I get opposite over hypotenuse, and I get this one, all right? So it's kind of like the first one is the cosine value, right? The second one is the sine value, all right? Because we're talking about this being an x, right, and this being a y. And there's a lot more time we could spend on the unit circle, but this is just kind of a quick reference so that you don't have to draw the bow tie over and over again. All right? So, if we're going to graph a polar equation like r equals 3 plus 2 cosine of theta, I believe it is much better understood if we just start picking some values for our angles. All right? And so I've given you a sheet of paper with this big unit, with this big polar graph on it. That's what I want you to use as we do this. So let's let theta be 0. If theta is 0, then I have 3 plus 2 times the cosine of 0. Well, the cosine of 0 is 1, isn't it? So if this is 1, then don't I have 3 plus 2, which is 5, right? So when the angle is 0, I come over 1, 2, 3, 4, 5. There's my point. There's no angle. The angle was 0. All right? Now, let's let theta be pi sixth. Well, pi sixth is 30 degrees, right? So now I have 3 plus 2 times the cosine of 30 degrees, okay? And the cosine of 30 degrees, we just reviewed that, is radical 3 over 2. So if I have 3 plus 2 times the square root of 3 over 2, the 2's cancel, and I have 3 plus the square root of 3, which is a decimal, all right? And if we refer to our calculator, 3 plus the square root of 3 is 4.73 approximately. This is approximately 4.73. So now on my graph, I use my 30-degree line, and I come up 1, 2, 3, 4, and here's 4. 4.73 is probably about right there. All right? Now let's do pi fourths. Theta equals pi fourths. So I will have 3 plus 2 times the cosine of pi fourths, which is 45 degrees, which we know up here is going to be radical 2 over 2. If I did it with the bow tie, I could find out the same thing. 2 times the square root of 2 over 2. The 2's are going to factor, and you're going to have 3 plus the square root of 2. All right, which is another decimal value. 3 plus the square root of 2 is 4.41. So I come up on the 45-degree line, and 4.41 is just a little bit closer than our last one. All right. So we've done pi sixths. We've done 0, pi sixths, and pi fourths. It would make sense to do pi thirds now. All right, and I'm going to go to another screen so I don't make this totally messy. If I use theta equals pi thirds now, then I'm going to have 3 plus 2 times the cosine of pi thirds, all right, which is going to be 1/2. So I have 2 times 1/2 here, which is just 1. So I have 3 plus 1, which is 4. So now on my 60-degree line, I'm right on the line 4. All right. Now let's do pi halves. Let's let theta be pi halves. So I'm going to have 3 plus 2 times the cosine of pi halves. Well, the cosine of pi halves is 0. So this is 3 plus 0, which is, we're back to 3. So when my angle is pi halves, which is 90, I'm right on the line 1, 2, 3, like that. Okay? And then we keep going. Now the next angle we should choose would be 120, all right? And so if I let theta be 120, all right, which is 2 pi thirds, I have 3 plus 2 times the cosine of that 120. Now, we can get this from that unit circle reference that I gave you. But let's think about this just a little bit for a second. Here's 120. I use my reference angle, which is 60. There's 30. This is the way we did it with bow tie. This is -1, 2, square root of 3. So this value, what I want you to notice is we're in the second quadrant. All scholars take calculus. In this quadrant, the cosine values are going to be negative. All right? So adjacent over hypotenuse, this is going to be -1/2 times my 2. So this is going to be a -1 added to that 3. And so now that value is going to be equal to 2. All right, so when I get over here to 120, I'm only going to be on the second circle. All right. And what happens is we keep going. Let's go to 135. I just want you to see the shape of this thing, because then after we get the first side, then the second side will happen much quicker. If I do 135, all right, so I have 3 plus 2 times the cosine of 135. Well, instead of regular radical 2 over 2, that's going to be negative radical 2 over 2 times 2 plus the 3. So that's going to turn into 3 minus the square root of 2, all right, which is going to be a decimal again. 3 minus the square root of 2 is 1.58 approximately. That gives me an idea of where to put it on the graph. So I use the 135, 1.58 is about there. All right? And then when I get to pi, or 180, I'm going to have 3 plus 2 times the cosine of pi. Well, the cosine of pi is -1. So this is 3 minus 2, which is 1. All right? So when I get to this 180 now, I'm back to 1 like this. Now, we're not done with this graph, but we are going to be able to speed up on the second half, and this is where that idea of symmetry comes in. If you look at this unit circle, as we continue going around, you see all of these values repeating, but they're negative here, okay? And they're positive over here. And so what happens is, as we keep going around the circle, like my next angle would be 210 degrees. All right? Well, if I let theta be 210 degrees, then I have 3 plus 2 times the cosine of 210. Well, just so that we understand, let's draw the bow tie on this real quick. 210 is 30 degrees past, so that's 30. This is 60. So this is going to be -1, 2, negative radical 3. All right. So when I do the cosine of that angle, I'm going to have 3 plus 2 times the negative square root of 3 over 2. All right, and so this turns into 3 minus the square root of 3, which is back to 1.27. I guess on our graph we didn't do 150, did we? But 150 would have been 1.27 as well. This one would have been 1.27. And when I come to 210, I'm back to 1.27 again. And every single one of these values is going to repeat all the way around. All right? So remember how we had, when we got to 135, we had 1.58. Well, we're going to have that value again when we get to 225. It's going to be that same value, what was it? 1.58. About right there. All right? And when we get to the next 30-degree value, we're going to repeat again. Okay? And it's going to keep repeating. So when we were at 240, it's going to be just like before that when we were at 120. Okay, our 120 value, the whole thing repeats all the way around. This one was 2, right? So when we get to 240, we're going to be right on the line at 2, just like we were up here at 120 when we were right on the line at 2. And then we're going to be right on the line here. And then we're going to keep following these values all the way around. Okay, at 300, we're going to be just a little bit past, just like we were at 60. I'm sorry, at 60, we were at we were right at 4. That's my mistake. We were right at 4. And then we keep growing just like we did before. When we get to 330, all right, we're about right here. And you get this shape that's kind of like a ball that's been squished. Like so. It's like a ball that has been squished a little bit. Now, I want to make it clear, I told you that all these values were repeating. If you get stuck repeating the values, you certainly can just keep right on going with plugging them in. You don't have to worry about trying to match up the repeating values. If that frustrates you, you can just keep plugging them in. I can do 3 plus 2 times the cosine of 240. And then I can do my bow tie work over here, which is going to make that be 60. All right, 30. So this is going to be negative 1, 2, negative radical 3. This one's going to be negative 1/2 times 2. This is like 3 minus 1, which is 2. You can go through and find all of these values piece by piece all the way around. All right, you don't have to try to match up the repeating things, but it can save you a little bit of time that way. And so when you're graphing these polar equations, like this one that we started with, my encouragement is to work through values, and because these problems are so long, we're not going to do as many of them. All right? The problems are very long. I mostly want you to see how cool they are and to see that they make some curious, interesting shapes as you work around, and that should hopefully guide you on how to graph polar equations today.